Yeah, so now we are going to look into candidate elimination algorithm. Okay. So what are we trying to find here? We are trying to find consistent hypothesis for a given set of examples. Okay. So this is your candidate elimination algorithm. Okay. So, and this is your question here. We did go through once how to divide it into a specific boundary, generic boundary and all that. And we were working up to it, probably up to the second hypothesis. We were up to the second hypothesis in the generic boundary. But I realized like many of you felt confused. So I think you should basically try to understand how this algorithm works so that it is pretty much easier for you. So I'll tell you first how what you're going to do, and then we'll go to the algorithm and then start working on the problem. So what we're going to do is set most specific and most generic boundaries. Okay. So because example one is a positive outcome here. So when it is a positive outcome, we'll go to the generic boundary and then we'll try to check whether at the generic boundary it is consistent or not. If it is consistent, we are going to retain it as it is. Otherwise, we will write the next general hypothesis. Okay. So the same way we'll verify for specific boundary. When the outcome is positive, we go first to the generic boundary. When the outcome is negative, we go first to the specific boundary. Okay. So when you go to the boundaries, the first thing that you do is check for consistency. Okay. If it is consistent, that's fine. If not, we are going to remove it. Okay. Okay, ma'am. So I'll explain the algorithm for you. Okay, so here, as you can see, okay, so they've initialized G to set up maximally general hypothesis in H. Like we are indicating H for the hypothesis and G is your generic boundary and S to the set of maximally specific hypothesis in H, where your H is again your hypothesis and the S is your specific boundary. Okay, so for each training example, okay, example one. So if your outcome or your target variable is a positive example, what are we going to do? Okay. Okay, so if it is positive, we are to go to the generic boundary. Okay, like I've told you, anything when it is positive, you go to generic boundary. When it is negative, you first go to the specific boundary. So the positive example, your first example, it has positive, right? Your outcome is positive. So we are to go to generic boundary and then check if the example is consistent with the hypothesis. Okay. So when I'm telling I'm going to check if the example is consistent with the hypothesis, okay, I have my hypothesis set as my specific hypothesis here is null. And my generic hypothesis here, this is indicated by question mark. Okay. So I hope you remember that it has 6 attributes. So hence we go for 6 set of nulls and 6 set of question marks here. Okay. So when I tell check if this example is consistent with the hypothesis. Okay. Which hypothesis are we going to check with? Since it is a positive one, we are going to check with this generic boundary first. Okay, that is what I'm trying to tell you. So if it is consistent, no change is required. Okay, if it is inconsistent, we will have to remove the boundary from the hypothesis. Then you go to the specific hypothesis and again check if it is inconsistent or consistent. If it is inconsistent here, then again you are going to remove. Then, okay, so here you find this. Okay, then we are going to remove this. Yes, that is when it is inconsistent, we are going to remove and add S to all minimal generalizations of H of such that. Okay, so what does this mean? Okay, this means that is null should be replaced with a specific value. Okay, so in your positive example, okay, in your positive example, you are facing, in your positive example, you are facing inconsistency and you have removed the boundary from the hypothesis. And the second part, you will have to go work with specific hypothesis, right? And now in your specific hypothesis, there is some inconsistency. What are we supposed to do? We are supposed to add yes to all minimal generalizations. So what does this minimal generalization mean in your positive or your generic boundary? Is your null should be replaced with your null should be replaced with the specific value. Okay, and your specific value should be replaced with a question mark. Okay, so are you able to get me? Like when we are going for the comparison, okay, you have your set of nulls and you have your set of specific. It is inconsistent. So this null will be replaced with a specific value. So what is the specific value we are talking about? These are your specific values: sunny, rainy, warm, cold, normal, high, strong, okay, your same and change, okay. These are your specific values. And when you are going to compare, go for a comparison with your specific value, okay, what happens is your specific value should be replaced with the question mark, okay. Your null will be replaced with a specific value and your specific value will be replaced with a question mark, okay. That is what happens with your positive example. Okay, so coming to your negative example, when it is negative, okay, when your target attribute or your outcome is negative, as in the case of your third example, you have a negative example here. So what are we going to do here? We are going to go to specific boundary, okay, and we are going to check for consistency. And if it is consistency, that's fine. If it is inconsistent, we are going to remove it, okay, then go to generic boundary, okay. So we need to consider one hypothesis at a time, okay. We are going to do something different here, okay. So I'll again repeat it for you. If it is negative, we go to specific boundary, check if it is inconsistent or not. If it is inconsistent, we are just going to remove it. Then go to generic boundary. What are we going to do in this generic boundary? We are going to consider one hypothesis at a time. Okay. And to see from this generic boundary, and then we need to see if this particular hypothesis is consistent or not. Okay, if it is consistent, we are going to do anything. If it is inconsistent, then we are going to remove the hypothesis first. Okay, so now what do we need to do? We need to add all minimal specializations of G, which is consistent with D. Okay, so what did we do here? We had to add to S all minimal generalizations, which meant null will be replaced with a specific value with null. Okay, here what happens here is if you have a question mark here, okay, then this question mark will be replaced with a specific value. Okay, so I'll probably just label it for you. You have your positive example. For your negative example, what happens here is your question mark, okay? This will be replaced with a specific value. Okay, and then if you have a question mark already, then it should be null in that case, as in your question mark, and then you have a specific value, that's fine. You are going to get a specific value. But then if you already have a question mark, then it should be null in that case. Okay. If you already have a question mark in the place and then it is going for a hypothesis with another question mark, then you can replace it with null. Okay, so this is where it began with, right? And from null to specific, specific to question mark, then again specific to question mark to specific value, and back to your question mark to null. Okay, so this is something like your you could say your addition, subtraction, or something like this. So this is how it works because this is how the algorithm is. Okay. So I will also add, I will include the link of this candidate elimination algorithm and how this works. Probably if you're still unable to understand this, I'm sure if you look into that, you will be able to understand the algorithm very clearly. Okay. So, okay, so let's just dive into your examples. Okay, we'll start working out with these examples. And the reason I had to make a video for this session is because, you know, in the classroom, even though I tell you we do it step by step, going for this video or something will help you to have a continuous understanding of what we're doing, and it will also help you to understand how you are really supposed to segregate and write them. Okay, so that is the purpose, and I'm making a video for you here. So we'll start with the problem. Okay, so just like we looked into it, we are going to start here. Okay, so you can have a partition. Okay, it could be any ways, but see that you really understand what you're doing. Okay, so what I do is I have a partition so that I usually have a partition so that there is a whole difference of what's really happening. Okay, so first you write your specific hypothesis. Okay, and then your generic hypothesis. Fine. So now we're going to start comparing. Okay, so first your hypothesis. So what is the first one? Your first one is positive, right? It is positive. So where do we go to? We are supposed to go to your generic, right? So we are going to compare your hypothesis, this generic hypothesis with your example one. Okay, so as you compare, what are we going to get? Our result is going to be the same, right? This is pretty much similar to what you did in your finding S algorithm. Okay, so this is fine. We have compared your GO and your example E1. And then this is your G1 hypothesis. And now after which we are going to compare is probably you can just write it down here. Compare, you have compared GO and E1. Okay, so here we are going to comparing is your hypothesis, specific hypothesis and example one. Okay, so since it has a negative outcome, which is expected, okay, but as a negative outcome as in comparing your this hypothesis with E1, okay, when you compare, it is negative, but still your outcome is positive, right? So hence it is inconsistent, okay. I will explain it for you again. This is your null, this is your hypothesis. We are comparing it with your attributes here. So null and sunny, null and warm, right? They're all not consistent, right? They're all inconsistent. So when the attributes are inconsistent, the outcome is expected to be inconsistent. But here it is consistent, right? So this is another thing that you are to remember. Okay. So what has happened here? Your attributes are inconsistent with your hypothesis, but the outcome, so what should be the outcome? The outcome should be inconsistent. Okay, it should be inconsistent, but it is consistent here. What do you think it adds up to? Okay, this adds up to inconsistency. Okay. Okay, probably if it is inconsistent here and it is also your outcome had also been inconsistent, then I can tell it is consistent. Okay, we're moving on the same parameters, but we have a different parameter here and there's a different outcome here, which means it is inconsistent. So what are we going to do? We are going to retain example one. Okay, we're not going to do anything as in we are not going to move forward with the hypothesis iteration. Rather, we are retaining. Okay, we are retaining. Okay, so that's it. Okay, and now going back to your second exercise example. So what was the outcome is positive, right? So positive, again, you can go to your generic. Okay, so what does your generic do? Comparing G1 and your E2. What do we get? It is the same again, right? So if you can remember, we had worked out till this, right? Okay, we had worked out till this. So this is fine. And now after this, we are going to go to your specific boundary, right? We are done with the generic. So now we are going to compare your S1 and your E1. So what happens here? Your S2, as you compare, I think this is the same which you worked out for your find this algorithm. So I don't think you would find it difficult to get your S2 hypothesis strong. This one, and for the last one, it is same. Okay. Okay, so that's fine. And coming to your, we have as of now, we've been working on, we've done with E1, E2. Coming to your E3, we have a negative outcome. Okay, negative outcome. What are we supposed to do? We're supposed to go to your specific boundary. Yes, we are going to a specific boundary. Okay, we are going to the specific boundary, that is compare S2 and E3. Okay, so since the outcome is negative, okay, so the thing is you are supposed to write the reason. You cannot simply write the outcome, but rather write the reason as to why you are retaining it or as to why you are removing it. Okay. Yes, so we have retained S2 as S3. So what was the reason for retaining E1 here? Because we did not have any hypothesis. Okay, we only had the only hypothesis were null here. Okay, so we had to retain E1. But as you go on, you work out, you have different hypothesis levels. So now you can retain S2 as S3. Okay, so now we are coming to your generic hypothesis. So this hypothesis, okay, so we are going to compare your G2 and E3. And what happens here is this hypothesis matches. That is, it is positive, but there is an inconsistency. Okay, there is an inconsistency because the outcome is negative. Okay, that is your G2. Okay, your G2 and E3 are matching up. Okay, matching up as in both are inconsistent, right? It is inconsistent, right? Inconsistent. They are matching up here. Sorry, they are consistent here. Okay, they are consistent here, but the outcome here is inconsistent. Okay, so what has happened here? Your hypothesis, your hypothesis is consistent. So what should have been your outcome? Your outcome should have been consistent, right? But it is no, which calculates up to inconsistency. So what are we going to do? We, as we have told, we are going to take up each hypothesis and work on it. Okay, probably if you remember looking back to your algorithm, okay, we are going to work on each of the hypotheses. So how do we do that? You have your G3. Okay, so how am I going to do it? G2 and E3, right? So this G2 with E3, I will have to take up Sunny. I will take up the first attribute, okay? Sunny and the first question mark or the generic boundary hypothesis. And the next one, warm and the generic hypothesis, okay? Then normal. Then it keeps on going, the pool, same, okay? So probably I will write it for you so that you can understand what's happening. Okay, and then we are taking a single hypothesis, okay? So what should be your next one? Your normal, right? Question mark, normal, right? We're not going to write anything for when attribute, okay? What is the reason? Because there is no opposite variable that is given, okay? So for your next one, it is right. So now what are we going to do? We have written it, okay, each as individual. And we've also not written when because it does not have an opposite variable. Okay, so now what are we going to do? We are going to check if all the 5 attributes are consistent. Okay, we're going to check if all the 5 attributes are consistent. If they are not consistent, we are going to remove them. Okay, and now we are going to compare each attribute with E1, E2, and E3 and figure out the consistency. So what happens here? We will have to compare Sunny with E1, E2, E3. Okay, we are going to compare with E1, E2, E3, and then the same way we are going to compare all the hypotheses, all the attributes here. Okay, we're going to compare sunny, warm, normal. Okay, these are all consistent. But when you look at your cool, when you look at your normal and cool, okay, what was your second? What was your second attribute here? Warm. So we have to check with it. Okay, we had a question mark, warm, question mark, question mark. Yes, it was consistent. Coming to your next one, it was normal, right? Question mark, normal, and question mark. So question mark, normal, right? So it is inconsistent here. So what are we going to do? We are going to remove normal. And what was the next one? It was cool, right? So it had to be, so it is supposed to be question mark, cool. It had to be cool and then question mark. Okay, so it has to be cool here when you compare with E2 and then question mark. When you compare here with E3, it had to be cool and then question mark all along the way, but then it is different here. So again, inconsistent. Okay, and your last one is same. Okay, so comparing E1, E2, okay, we have question mark, and same here, right? So what are we going to do? We are going to remove normal and cool. Okay, so they are inconsistent. And another thing, either you retain a hypothesis or you replace a hypothesis or remove something, okay? Whatever you would try to write down the statement, okay? Okay, so we're done with this. Okay, and now coming back to your E4. Okay, so coming to your E4, you can see that your target variable is positive. So what do you do? So since it is positive, we are here with S4. Okay, comparing your S3 and your E4. Okay, so what is your output? So this is pretty much the same, right? So coming back to your, then coming to your G4, what are we going to do? We are taking it as separate hypothesis, right? And we are going to compare each attribute, okay? Sunny again with the examples, Warm again with the same examples, and then the last hypothesis too with the same examples. And if same attribute is it has inconsistency, then the attribute is removed. Okay, so now we are going to compare the first hypothesis. Okay, so when I tell it's sunny, question mark, question mark, question mark, it is consistent. What is the outcome? Consistent. Okay, the second sunny, question mark, question mark, question mark, it is consistent. Yes, it is consistent. Here it is not sunny, rainy, which means, and the question marks are here, it does not exist here, right? So it is inconsistent and your outcome is also inconsistent, okay, which means it is fine. And then coming back to your last one, it is sunny, yes, and question mark, and if this your hypothesis is consistent, your outcome is also consistent. Okay, so it means we are retaining sunny. Okay, and coming to warm, you warm. How does this work? You will check with the first one, question mark warm, question mark, consistent, yes, consistent. Then your second one, yes, your hypothesis is consistent. Your outcome is also consistent. Okay. Your third one, your hypothesis is inconsistent. Your outcome is also inconsistent. So it is fine. Okay. Your fourth one, yes, your hypothesis is consistent. Your outcome is also consistent. And so we are retaining one. And then your last one is same, right? So comparing same question mark, same. Is it consistent? Yes. Okay. So what is your outcome here? Yes, it is consistent, right? So your sunny, yes, it has same question marks and then same here, consistent, yes, consistent. But here, if you look into it, what happens here? It is inconsistent. Okay, your hypothesis is inconsistent and your outcome is also inconsistent. So it's fine. We're coming back here to your E4. Your hypothesis is inconsistent, but your outcome is consistent. Okay, so what do we do? Then we are supposed to remove your same attribute. Okay, meaning which we are not going to retain same. Okay, so finally, so this is your hypothesis for your generic boundary. This is a hypothesis for your specific boundary. And so what are we going to do now? Since there are more than one hypothesis, okay, we are supposed to finalize it with a single hypothesis, right? So since there is more than one hypothesis, we need to write few more possibilities, okay? So we are going to write few more possibilities. So when I tell we are going to write few more possibilities, I want you to have a look into the hypothesis which you have looked into. Okay, if it is a positive, what are we going to do? Null will be replaced with a specific value. If there is a specific value, then it should be replaced with a question mark. When it is negative, question mark will be replaced with a specific value. And if a question mark already exists, it will be replaced with null. Okay. So remembering this from the algorithm, we are going to write the hypothesis. Okay, so let's write the existing specific boundary here. That is your sunny, warm, strong, and your question mark. Okay, so here let's write in generic here, sunny. That is your last two hypotheses. Okay, so now just like we are comparing each hypothesis with the E1, E2, E3, we are going to compare hypothesis. Okay, first Sunny with Sunny with the first hypothesis. Okay, so now when we start comparing, okay, Sunny and Sunny, that's fine. Okay, this is all that you are segregating your final hypothesis. Okay, so okay, we are writing up Sunny. Okay, and let me remind you here we are not going for a full hypothesis comparison with another, but rather we are comparing each attribute or each specific value. Okay, each specific value, Sunny and Sunny. Okay, then again Sunny and warm, Sunny and strong. Okay, that is how it is. Okay, so if I'm going to compare this Sunny with this generic, okay, this generic hypothesis with this specific hypothesis, okay, and compact Sunny, it is consistent, okay, then it's fine. Then I'm going to compare now with my second specific value form, okay. So comparing the same, I will be getting question marks, right? And then I'm going to compare again the same with strong, okay. I'm comparing. So I hope you, when you're doing this, you remember the hypothesis which we looked into, where null is replaced by specific value, where specific value will be replaced by null. Okay. Yes, we have replaced, we are here, we have replaced this with a form with a question mark, right? Okay, and we're redoing. Okay, so now this is your second hypothesis. Okay, and now if you're going to compare warm and your Sunny and warm, you will again get the Sunny warm. That is this hypothesis. But since we've already written it or it already exists, we're not going to repeat the same. Okay, so we can compare the same with strong. So, mhm, yes. So what did we do here? We took up the hypothesis that we had here. That is, we had three hypotheses, one from specific, two from generic, and then we started comparing the hypothesis for the total number of possibilities that existed. Okay, whereas in each hypothesis or each specific value was, if the Sunny was compared to the Sunny specific value from this generic was compared to the specific hypothesis, and then warm was compared. So now what do we have here? We have a total number of possibilities. Okay, total number of possibilities for this hypothesis is 3. Okay. Okay, so I will once again tell you what we have done. Okay, so before you begin solving this problem, try to remember the algorithm and the steps. Okay, so we are going to begin when you look into a problem. asking you to solve it using candidate elimination algorithm, the first thing you're going to remember is you have two things, specific and generic boundary. Okay. And then these are the rules which you are going to execute in your last iterations. Okay. If it is positive, this is how you are going to replace. If it is negative, this is what is going to happen. Okay. So if it is positive, you go to generic. If it is negative, you go to specific. Okay. So since it was positive, we started comparing. It was done. And then you went to negative, right? If it is inconsistent, what do? We retain, right? We retain. And then again, we went to G2, G3 and everything. And we found the inconsistent value in the generic. When it is inconsistent in the specific, we simply retain, okay? When it is inconsistent in your generic, we start dividing them into their individual specific values, okay? Instead of having a single hypothesis, it is divided into single specific values, okay? As you can see here. And then we compare each specific value. If suppose we are working with G3, we will be comparing the specific value with E1, E2, and E3 and trying to find out the consistency and inconsistency. And the inconsistent attributes are removed. Okay. I will tell it again for you. For sunny, warm, normal. Okay. For we remove normal and cool, right? Okay. For normal and cool, what happened here for normal? It was fine. We had normal and then it was consistent. But here it is inconsistent and here it is consistent. So it represents inconsistency. So we had to remove normal and the same happened with cool, right? So then we had three attributes and the last one was positive. Okay, so it was fine. We worked on G4 and S4, it was fine. But still we have three hypotheses, right? And now we had worked to find the what are the number of possibilities that are going to occur with these hypotheses. So this is where you will have to remember what you learned in your algorithm, which specific value has to be replaced with what. Okay, so here what did we do? The same thing. We are comparing specific values with this hypothesis, right? So sunny and sunny gave us warm, and again, so your question mark and your warm, right? Question mark and warm was replaced with a specific value, okay? Your question marks. Then again, we worked on with the same sunny and strong and then warm. And if there is a repetition, we try to remove it. That is, we do not repeat a hypothesis, okay? So what is the total number of possibilities for this hypothesis? It is 3. So I've also added the video link for this algorithm, okay? An explanation for this candidate elimination algorithm. So if this is still yet not clear for you, I highly recommend you to watch that and then you can start with solving out the examples.